Hello everyone, hope you're all doing good. Dr. MK here and welcome back to our channel. If you are watching our channel videos regularly, you will be aware of that I have made 3 videos based on nucleophilic substitution reactions. And to conclude all the 3 videos, I'm going to discuss multiple choice questions based on nucleophilic substitution reactions. I've selected 15 questions which are based on SN1, SN2 and SNi reaction, and I'm going to discuss all the 15 questions in this video. And if you are new to our channel, I ask you to watch all the 3 videos first and then you come back here for the question discussion part. Shall we start? Question number 1. Which is the most reactive towards SN1 reaction? They have asked SN1 reaction. So you know that in SN1 reaction, the rate determining step is formation of carbocation. So if you want to know the reactivity of a molecule, you need to know which carbocation is more stable. From that only we need to find out which is more reactive alkyl halide. So for the reason, we need to draw the carbocation of all the 4 species. The first one will give diphenyl methyl cation. The second option will give phenyl ethyl cation. Third one will give diphenyl ethyl cation. And fourth one will give benzyl cation. The first species is an example of secondary carbocation, and second one is also an example of secondary cation. Third one is an example of tertiary cation, and fourth one is an example of primary cation. So you know that the carbocation, that is tertiary carbocation, is the most stable. Fine. So that means this among all the 4 carbocation, this cation is the most stable. That means it is formed very easily. That means once it is formed, the second step will be very faster. So among the 4 species, that is the option C, this compound will be the most reactive because it will give most stable carbocation. That's it. Question number 2. When the concentration of alkyl halide is tripled and the concentration of nucleophile OH minus is reduced to half, the rate of SN2 reaction increased by, they are asking the question. So the reaction that they have given is, that is SN2 reaction. Immediately you need to look at the SN2 reaction rate law. In SN2 reaction, rate is directly proportional to the concentration of alkyl halide and the concentration of nucleophile. So that is what we have already discussed. So instead of this nucleophile, they have clearly given that is OH minus is a nucleophile in this case. So what they have asked is, that is alkyl halide concentration is tripled. So that means they are increasing this by 3 times. And the nucleophile concentration is reduced to half. That means instead of 1, they have reduced into 1/2. So what is the change in rate? That is a question. So you need to divide this 3/2. So that means you will get 1.5. So that means the rate is increased by 1.5 times. So the right answer is option B. Question number 3. Arrange the following in order of decreasing tendency towards SN2 reaction. Before going to that, you need to know SN2 reactivity of alkyl halides. So that means the most reactive alkyl halide is methyl halide, and then you have primary alkyl halide. Second one is secondary alkyl halide, and finally you have tertiary alkyl halide. So this is a general reactivity order. Based on this, you need to identify all the 4 molecules in terms of primary, secondary or tertiary. The first alkyl chloride is an example of primary. Second alkyl chloride is an example of secondary. Third alkyl chloride is an example of primary. and 4th alkyl chloride is an example of tertiary. So among them, primary will be more reactive, but you have two molecules, that is compound 1 is also primary, compound 3 also primary, and among them which is more stable. So I am redrawing that structure 1 and 3 here. This is structure 1 and this is structure 3. Fine. So among them which is more stable, I have already said that in SN2 reaction, when bulkiness increases, SN2 reactivity rate decreases. So that means when you compare compound 1 and compound 3, in compound 3 you have a methyl group, so which is quite larger group. So that means that compound 3 consists of one extra bulky group. When the bulky group increasing, obviously the SN2 reaction rate will be decreasing, because in SN2 reaction transition state will be formed. So that means if the molecule is having more bulky group, means there will be huge static hindrance in the transition state. So that means the transition state will become less stable. So in order to avoid that steric repulsion, that less bulky molecule will be more reactive in nature. That means that is compound 1 will be more reactive than compound 3. Fine. Remaining things are very easy. The second compound is an example of secondary alkyl halide, and third compound is an example of tertiary alkyl halide. So that means the next reactive molecule will be 2 and the least reactive molecule will be 4. So the right answer is, that is 1, 3, 2, 4 is the right answer, option B. Question number 4. In SN1 reaction, racemization takes place due to, that is a question they have asked. So let me take this molecule. Fine. So this configuration is 1, 2, 3. 1, 2, 3 are arranged in clockwise direction. The molecule configuration is R. Now this molecule is treated with water, that means solvolysis or hydrolysis, otherwise known as SN1 reaction. So what is the first step in SN1 reaction? That is a formation of carbocation. That Br minus will be leaving, and as a result the carbocation intermediate will be formed, which is sp2 hybridized trigonal planar geometry. That means this is planar molecule. Now water molecule is approaching this carbocation from the front side or from the back side. So let us assume the front side attack is A and back side attack is B. So according to path A, you would get OH is placed at front side and hydrogen is placed back side. Here you have methyl group. Now here in path B, OH is approaching the cation from the back side. Here you have OH and front side you have hydrogen atom. Now if you happen to look at the configuration of product here, that first product A configuration is, this is 1, 2, 3, the configuration is R, and second product configuration is S. So that means the reactant, that means the reactant R is giving 50% R configuration product and 50% of S configuration product. So in product A, that is a configuration of the reactant is retained. So that means this is retention of configuration. And in product B, that is a configuration of reactant, that is R, is converted into S. That means opposite configuration is formed. So this is known as inversion. So that means 50% of retention product and 50% of inversion product will be formed. So let us look at the options here. Inversion of configuration is not the answer. Retention of configuration is not the answer. Conversion of configuration, it is not even related to this SN1 reaction. And both A and B, that means both inversion as well as retention will be obtained. So that means right answer is option D. Question number 5. Which of the following order represents the increasing order of reactivity towards bromide ion under SN1 reaction? So again they have asked SN1 reaction reactivity order. So what you need to do is you need to draw the all 4 species carbocations. The first vinyl chloride will give vinyl cation. The second one is ethyl chloride will give ethyl cation. Third one is methyl chloride will give methyl cation. And fourth one is allyl chloride. Which will give allyl cation. So now you need to identify the stability of all 4 carbocations. Once the stability of all 4 carbocation is identified, means then the reactivity of SN1 reaction will be very easy. So you need to identify the stability of all 4 carbocations. So among the 4, the most stable carbocation is vinyl cation, because this cation can be stabilized by neighboring pi bond. So that means it is resonance stabilized. This is the most stable. And next one we have that is cation 2, that is primary cation, because you have 3 hyperconjugation forms. Next one you have methyl cation 3. And the least one is vinyl cation. This vinyl cation will not form that easily because that is unstable. So among the 4 species, the stability order of carbocation goes 4, 2, 3, 1. Now the stability of carbocation directly proportional to SN1 reactivity. So that means the same answer can be given for SN1 reactivity. So in SN1 reactivity, the most reactive species, that is 4, and second one, then third one, and the least reactive is compound 1, that is vinyl chloride will be least reactive in SN1 reaction. That means 4, 2, 3, 1, the right answer is option A. Question number 6. In SN1 substitution reaction of the type, they have given an alkyl bromide which is treated with chloride ion in DMF as a solvent. If the DMF as a solvent is given, means that the reaction is SN2 to form alkyl chloride as a product and the bromide will be leaving. Which one of the following has the highest relative rate? Just before I have explained that in SN2 reaction, methyl halide will be the most reactive, followed by primary, secondary, tertiary. So this is a reactivity order. And you need to identify the nature of all the 4 alkyl halides. The first alkyl halide is an example of primary. The second one is secondary. Third one is tertiary, and fourth one is primary. So among the 4 species, primary alkyl halides are more reactive. That is species A or species D. So among them, both are primary. Among them, which is most reactive? So in compound A, that is N-propyl bromide, so this bromide is attached with a 3-carbon propyl group. Whereas in the last case, that is ethyl bromide, this bromide is attached with 2-carbon ethyl group. So which is quite larger? Obviously, 3-carbon N-propyl group is bulkier compared to 2-carbon ethyl bromide. So which is most reactive? That means the species which is having less bulkiness will be most reactive in SN2 reaction. In that concept, that is option D is a most reactive. Right? Once again I am writing. When bulky group increases, SN2 reactivity rate decreases. Question number 7. Consider the following bromides. the correct order of SN1 reactivity is. So again they have asked SN1 reactivity, that means you need to draw the intermediate of all the three species. The first species A will give a primary cation. Second species B will give an allyl cation. This is an allyl cation. Third species C will give a secondary cation. So among the three species, which is most stable? Obviously you know that this allyl cation is most stable because of resonance. So the most stable cation is most reactive. So that means the most reactive species is B. Followed by you have the next stable cation is, that is secondary cation, C. And least reactive will be primary cation, because the primary cation is least stable. That means it will not form easily, so that the reactivity will be lowest. So that is A. So BCA is the right answer. The right answer is option A. Question number 8. In the given reaction, identify the product and the type of reaction. So you are given a chiral alcohol and it is treated with thionyl chloride. So when an alcohol reacts with thionyl chloride, that means the reaction is SNi mechanism. You know that. And in SNi mechanism, the product configuration is retention of configuration product. So these are the things that we have already discussed in the previous video. Right. So now what happens here? This alcohol reacts with SOCl2. That means this OH group is replaced by Cl group with retention of configuration. That means OH group is present front side to the plane. So that means the Cl also will be replaced at the same side. So that is a retention of configuration product you need to look at. So that means in the case option A it is given and option C also given. That is a retention of configuration product. That means same side the chloride will be attacking. So but the mechanism they have asked. So that first case the mechanism is SN2 mechanism. It is wrong. And third one, that is option C, in that case they have given SNi reaction as a mechanism. That is the right one. The right answer is option C. Question number 9. Arrange the following in decreasing order of solvolysis. I have already discussed solvolysis means SN1 reaction. They have asked reactivity order. So that means you need to draw the carbocation intermediate of all the 4 species. Compound P will give this kind of carbocation. Compound Q will give triphenyl methyl cation. Compound R will give benzyl cation. And compound S will give allyl cation. So if you identify the stability of all 4 species, then the stability of carbocation is directly proportional to the reactivity of alkyl halide SN1 reactivity. So among the 4 species, the most stable will be Q, because this cation is stabilized by 3 phenyl rings. This is the most stable. And the next most stable is, that is benzyl cation, that is species R. And followed by you have allyl cation, that is S. And the least stable carbocation is, that is P. So this is an example of a bridgehead cation. Bridgehead cations are unstable in nature because it cannot attain the planarity. I have already discussed in carbocation related videos. You can check the videos in our channel. So this bridgehead cations will be the least stable. Cation will not form at bridgehead position that easily. So that means the least reactive is species P. That means this carbocation stability is also considered for SN1 reactivity order. So the most reactive is alkyl halide Q, then R, then S, followed by you have P. So Q, R, S, P is the right answer. The right answer is option B. Question number 10. Which of the following will be least reactive in SN2 reaction? So the first species is an example of secondary alkyl halide. Option B is an example of secondary alkyl halide. Option D is an example of secondary alkyl halide. And option C is an example of bridge-end alkyl halide. The answer is, that is option C. Bridge-end alkyl halide will be the least reactive in SN2 reaction. Why? Let me explain the reason here. So this compound can be redrawn in this way. Now this bromo group is placed front side to the plane. So that nucleophile in SN2 reaction, always the nucleophile will approach backside to the leaving group. So the leaving group is present at front side. So the nucleophile has to approach from the backside, right? But in this case, that ring skeleton will be hindering the backside attack. So this backside attack is not possible in the case of bridge-end species. So that means when a halide is present at bridge-end position, means that SN1 reaction also will not take place. Previous case I have explained, and SN2 reaction is also will not take place. So the least reactive will be option C. Question number 11. A solution of S1-chloro-1-phenyl ethane in toluene racemizes slowly in the presence of small amount of antimony pentachloride due to the formation of. So let me draw the reactant configuration and the structure. So this has 1, 2, 3. 1, 2, 3 are arranged in anticlockwise direction. So the configuration is S. Right. So this is S1-chloro-1-phenyl ethane. When it is treated with antimony pentachloride, you will get a racemic product. Product of the same molecule. How it is happening? You know that antimony pentachloride is an example of Lewis acid. A Lewis acid requires a pair of electron. So that means it takes this carbon chlorine bond electron, that means it takes this Cl minus, that is carbon chloride bond is broken, and it takes this Cl minus and it is leaving us SbCl6 minus. And as a result, a carbocation intermediate will be formed. So this carbocation has sp2 hybridization, the geometry is trigonal planar. Now this chloride, which is left in the first step, is coming and attacking here. It can approach from the front side or from the back side. So leading to the formation of two products. So this is front side attack, and this one is backside attack product. So this is A, this is B. So 50% of retention of product and 50% of inversion of product. So that means racemic mixture is taking place. So that means, what is the reason for the forming of racemic product? That is, the reason is formation of carbocation intermediate is a reason. So if you happen to look at the option, that is option A is the right answer. Question number 12. Identify the major product in the reaction. So this is a dichloro compound. You can see here this has a chlorine part and this also a chlorine part, and both carbon atom coming under primary carbon. So now this compound is treated with sodium iodide along with DMF. You know that when DMF solvent is given, then the reaction is SN2 mechanism. Now which part of this molecule reactant will be undergoing reaction with sodium iodide? You know that sodium iodide charge separated in Na plus and I minus. Now the I minus can approach this carbon atom, or the I minus can approach at this carbon atom. Both are primary, but among them which is more reactive, that is a question. So in the left end you can check here, this primary carbon is connected to a carbon which is having two bulky groups. So that means that when the nucleophile is approaching this carbon, means this left side carbon, it will face too much steric hindrance at this transition state. So it will not approach this carbon atom. Whereas at the right hand side primary carbon atom, if you happen to look at, so this carbon atom is connected to a CS2 group only. It has 2 hydrogen atoms which will not cause much steric hindrance. So the attack will be easier. So this leads to the formation of a product like this. Selectively, one of the chloride will be substituted by this iodide. So this is a chemoselective reaction, you can call it as. So that means the right answer is option B. Question number 13. This chiral alcohol is treated with thionyl chloride along with pyridine. So I have already explained in the previous video, when you treat an alcohol with the thionyl chloride, pyridine, you will get alkyl halide only. But the reaction undergoes via SN2 mechanism, and the configuration product will be inversion of configuration. So that means that nucleophile will approach opposite to the leaving group. So that means the leaving group OH is present at backside to the plane. So the incoming group chloride will be approaching from the front side. You can check the mechanism of SNi reaction, that is, this is known as Darzan's halogenations. I have already explained in the previous video. So this process is known as Darzan's halogenation. You can check the video. And in this case, the chloride will be approaching from the front side because the OH group is present at the back side. So the right answer is, that is option C. It will give this product. Question number 14. Which is the most reactive compound by SN1 mechanism? That means in SN1 mechanism they have asked. So immediately you need to draw the carbocation intermediate. And you need to identify the nature of all these substituents. In the first species, you cannot find any substituent here at the benzene ring, because here there is no electron donating group and there is no electron withdrawing group connected to this phenyl part. Just ignore that the cation part. And in the second case, you have a methyl group. So this methyl group comes under electron donating group category. Third one, you have methoxy group. This methoxy group comes under electron donating group category. Fourth species, you have chloro. So this group is coming under minus I effect and a plus R effect. So it has. So among them, minus I will be dominating. So we can call it as a mild electron withdrawing group. Right. So we know that a carbocation is connected to electron donating group will be more stable. So in that case, compound B can be more stable or this C can be more stable. There are two kind of answers. Among them, which is more stable? That means compound C is the most stable. Why? Because this cation can be stabilized by methoxy group, which is a strong electron donating group. So that means the lone pair of oxygen atom gives its electron to phenyl ring, and this cation is stabilized by resonance structure. Whereas in the case of methyl, this cation can be stabilized by hyperconjugation effect only. There is no resonance effect involving in this case. So that means the resonance is more powerful than hyperconjugation. So in that aspect, that is compound C will be the most stable and this alkyl halide C will be the most reactive. Question number 15. The major product X in the given reaction is. So this species is known as sodium thiophenoxide. Sodium thiophenoxide. Now this species reacting with this reactant which is having chloro group benzene ring and the bromo group at this alkyl chain. The question is which will be undergoing reaction. and which type of reaction will be taking place. And there is a clue given, NN dimethylformamide is a solvent, that is DMF is a solvent. If you use DMF, then the reaction mechanism will be SN2. First, let us discuss which will be undergoing reaction. For example, this S minus is approaching this benzene ring, and thereby the Cl minus is leaving, means then this reaction is known as aromatic nucleophilic substitution, SNAR reaction. Whereas this S minus is approaching at this carbon chain, and thereby this Br minus is leaving, means this is known as aliphatic nucleophilic substitution. Which is faster? Always aliphatic nucleophilic substitution. Is faster than aromatic nucleophilic substitution, otherwise known as SNAR. So in that case, that is the attack of S minus at benzene ring will not be taking place. That means this is known as ipso attack. I am not going to discuss SNAR reaction in detail right now. I will make a separate video. And this part, that is aliphatic nucleophilic substitution, will be more faster. From this case, we just ignore that options B and option D. Now our options are very clear. That is, option A can be the answer or option C can be the answer. Now I have already said the reaction is undergoing via SN2 mechanism. That means the nucleophile has to approach from the back side to the leaving group. The leaving group is present at front side here, Br is present front side, so that S minus, that is thiophenoxide, will be approaching from the back side. So that means you will get this compound as a product. This is a product. So the right answer is you have option C. So I strongly believe that this multiple choice questions video based on nucleophilic substitution reactions is very much useful to you. And if you find so, you can like the video, share your opinion in the comment section. Do not forget to subscribe our channel. And I will meet you all in the next video with an interesting topic. Until then, take care. Bye.